Welcome back to my channel. Take care for you. This is Harika. Up to now, in previous video we have discussed about the Avl trees. Now we are continuing the same part, Avl trees, and the operations of the Avl trees, how we rotate the balancing tree from unbalanced tree to balanced tree. Let's get started our actual video. Please subscribe to my channel. If you like this video, please share it to your friends. Now we are going to discuss about the operations on the Avl tree. Up to now, already we have discussed about the operations on the trees. Already we have discussed about the operations on the trees, binary tree, binary search tree, etc. In every tree we supposed to do the same thing, searching, insertion, deletion, etc. And when we go with the searching, here search operation is similar to the BST binary search tree. So we need not to discuss much about here, but the height of the elements is n. Then the order of searching is order of log n. If there is an n elements, for n elements. Now we are moving to the insertion. When we insert an element into the Avl tree, these also a same procedure, will follow the same procedure which is done in the BST, but when we go with the insertion, here the major constraint over here, the balancing factor. Major constraint is balancing factor. In insertion operation, if we check the balancing factor of entry, that should be in between, the balancing factor should be in between -1, 0 and +1. But when we go with the balancing factor -2 or +2, then the tree is an unbalanced tree. Then the tree is unbalanced tree is not an Avl tree. So by considering this constraint, this particular constraint, we are going with some observations. First we will check the observations. Whatever the observations we have made here are, first one, check the balancing factor of an unbalanced tree. We'll check the balancing factor of an unbalanced tree. That should be only among -2, -1, 0, +1, +2, like this. Apart from this, then we'll go with the other areas. After insertion, the node balancing factor is either +2 or after insertion of an element into the Avl tree, for the nodes whose balancing factor is either -2 or +2, then we will go with the corresponding rotations that made for the -1, and will balance the -2 and +2 to the +1 and -1. This is the one of the observation we have to do. And one more thing, the insertion may be or may affect the balancing factor of the only nodes that appear in the path from the root to new node inserted. So insertion, here the insertion may affect only in the balancing factor of a only the nodes only the node that appear on the path. Route to the new node that is inserted. New node that is inserted. This is the another observation. And finally we'll observe the another thing. We'll do the another thing. The next ancestor of the A of the newly balanced tree, whose balancing factor is either +2 or -2, that initiate the rotation. So finally we'll meet the rotation. Finally we'll meet the rotation for the nodes having balancing factor of +2 or -2. So we'll meet the sum of the rotations for the imbalanced trees, that is whatever the rotation we have made over here are the rotations. LL rotation, LR rotation, RR rotation, RL rotation. These are the 4 rotations we have done to balance the Avl tree, unbalanced tree, from unbalanced tree to balanced Avl tree. Okay, let's get start our insertion operations. First, LL rotation. LL rotation. Here generally representation of the LL rotation can be shown by using the example, but it leads the LL type of imbalance. If we consider the imbalance occurred in the left subtree of left subtree, then we'll go with the balancing, we'll rotate the node from place, certain place to another place, and we'll balance the tree. Okay, we are considering this example. Let us consider the tree. This is some of subtree B, either it may be C or one node. Here the 2 nodes are BR. So here the balancing factor is 0. Here the balancing factor is +1. So this is an balanced Avl tree. This is an balanced Avl tree before insertion. Next we are inserting the element X into this tree. We are inserting element X into this tree. Then it will show like this. See our right subtree and B. For B, this is the B or right subtree to the B, and left subtree we have inserted the X element. Why? Because I am representing the dotted representation, because this makes the tree as the unbalanced one. So when we consider this is this tree, this is an unbalanced tree. This is an unbalanced Avl tree. So we are rotating this unbalanced tree to balanced tree. After inserting X element, the tree became the unbalanced Avl tree. Now we are rotating the LR rotation. After LL rotation, it will be like this. We are rotating the B to C. We are rotating here the B to C. We are making the B as parent node, root node, C as child node, because the C is the greater element than the B. So it will be placed at the right side of the B. Then we are placing the X over here. This made the changes, that's why I have placing the dotted representation. XL and BR CR. Why I am placing the BR in the place of C? Because the B element is less than C element when we go with the binary search tree. So if we place at the right side of the C, then it will be the child node to the B, child node right part of the B, then it will be the left part of the BR, because this is less than C. That's why this is greater than B but less than C. That's why we are making BR at the left side. Now we can say that height of this is 0, height of this is 0, height of this is 0. How we can consider the height of the tree? Left minus right subtree 0, left minus right subtree 0. So we are making the unbalanced tree to balanced Avl tree by moving LL rotation. We are moving the left part of the left part of the tree to the root node, and we have made the left part to left part rotation. We have done the left part rotation, so it is nothing but the LL rotation. Next we are moving to the LR rotation. LR rotation. LR rotation. Let us consider the another example. LR rotation can be done at the side of the right subtree of the left subtree. Right subtree of the left subtree. Then we will go with the balance. We will balance the Avl tree by using the left part of the right subtree, by moving left part of the right subtree. A, CR, AL, AR. Here the balancing factor is 0. Here the balancing factor is +1. So this is also a balanced Avl tree before insertion. Balanced Avl tree before insertion. After inserting X, after inserting X value, we can see like this. CR A. Here we are inserting X at the right part of the AL, right part of the left subtree. X is placing over here, right part of the left subtree. So we are moving the right subtree. We are moving the right subtree over here. XL, XR, XL and XR, CR. These when we consider here the -1 balancing factor, here the +2 balancing factor, we can see by seeing this tree, this is an unbalanced Avl tree. This is an unbalanced Avl tree. Now we are moving by moving LR rotation. By moving LR rotation, right part of the left subtree. By moving right part of the left subtree, we can rotate the values and we will make the Avl tree as balanced. we are making this is the root node and A is the left child and C be the right child, because if we have placed A at the X at the right part of the right part of this child, then A is less than X. Then if we rotating this element to over here, then we will consider this is as the left child and this is as the right child, because this is the in left part of the element C is greater than the left subtree. C is greater than the left subtree, so it will be the right child. As it is AL, XL, XR and CR. Here it will be the -1, height will be the 0, height will be the 0. So we have balanced the tree. This is an balanced AVL tree. In this way we are rotating the LL rotation and LR rotation. Now we are moving to the up to now we have done the LL rotation and LR rotation. Next we are moving to the RR rotation. Next we are moving to the RR rotation. This is the right part of the right subtree. We are inserting the value at the right part of the right subtree. If it is unbalanced, then we will move the elements. We will rotate the elements. Okay, we are considering the same example. C, left subtree of the C, D, left subtree of the DL, right subtree DR. Here the balancing factor 0, -1. So this is an balanced tree. This is an balanced AVL tree. Previously, this is a balanced AVL tree. Now after inserting X value at the right part of the right subtree, same as it is CL, D, DL, X. Here we are placing the X, XL, XR. We are inserting the value. Here the balancing factor is 0. Here the balancing factor is -1. Here the balancing factor is -2. Then this is an unbalanced AVL tree. So we are getting the balancing factor as -2. Unbalanced AVL tree. RR rotation. After doing RR rotation, we will balance the AVL tree by using, we are moving right part to the node. Similarly, here we have checked about the first LL rotation. We have done the B as the root node. Here we are doing D as the root node over here. RR rotation. Root node is D. Then left child is C, right child is X. So CL over here, DL over here. In the left part, DL is at the left part, and the left part we consider the D is greater than the C. So we'll place the DL over here. XL, XR. In this way, here if we consider here the 0, 0, 0. So this is an balanced AVL tree. Balanced AVL tree after rotating the RR rotation. After doing the RR rotation. Next we are moving with the RL rotation. RL rotation. RL rotation. So this is the right part of the left subtree. Sorry, this is the left part of the right subtree. Let us consider an example. Cl E D dl dr er. Here the balancing factor is 0, here the balancing factor is 0, the balancing factor is -1. This is a balanced AVL tree after doing the balancing factors.